Hello, my dear students. Let us take one more example on Euler's and Rankine's formula. A hollow circular section, 2.8 meter long column is fixed at one end and hinged at the other end. External diameter is 150 mm and thickness of wall is 15 mm. Rankine's constant alpha, that is equal to 1 divided by 1600, and sigma c is equal to 550 MPa. Compare the buckling loads obtained by using Euler's formula and Rankine's formula. Also find the length of the column for which both formulae gives the same load. Take E is equal to 80 GPa. See here, two questions are there. First thing, you have to calculate what is Euler's crippling load, and after that you have to find what is Rankine's crippling load, and then you have to compare. Once if you finished with that, you have to find what is the length of the column. Now let us start. We'll see what is given here. So the length is given, that is 2.8 meter. So 2.8 into 10 raised to 3 millimeter, so equal to 2800 mm. Next, what is given? External diameter is given. Instead of capital D, here it is taken as D naught. Okay, outer diameter. So external diameter is equal to 150 mm and thickness is given 15 mm, and alpha, Rankine's constant, is equal to 1 divided by 1600, and sigma c is equal to 550 MPa or 550 Newton per millimeter square. And E is equal to 80 GPa or 80 into 10 raised to 3 Newton per millimeter square. Okay. Now we'll see first inner diameter. We don't know here. We have to calculate that because Euler's formula that requires moment of inertia. So to calculate moment of inertia, we should know what is capital D and small d. Even to calculate area, we should know what is capital D and small d, right? Because this is a hollow circular section. So how to find capital or small d or inner diameter? Inner diameter is equal to, let us take it as di. Okay, inner diameter is di is equal to capital D minus 2t. I have solved in one problem in the last class, so I have told that inner diameter is equal to capital D minus 2t. Okay, so total depth minus 2 times of the thickness. Here it is taken as DO, outer diameter. So di is inner diameter. Okay, so di is equal to, now here this is nothing but di. Okay, di, that is equal to d naught minus 2t. D naught, outer diameter, is 150 mm minus 2 into thickness is 15. So you get 120 mm, that is inner diameter. Now you have to calculate what is the cross-sectional area. A is equal to pi divided by 4 into d naught square minus di square. That is nothing but capital D square minus small d square. Here it is written outer and inner. So d naught square minus di square into pi divided by 4. Substitute the values, you get area is this 6361.725 mm square. Next you have to calculate what is moment of inertia. What is moment of inertia? The formula for a circular section, hollow circular section, is pi divided by 64 into d naught 4 minus di to the power 4. Right? Here, this is nothing but capital D raised to the 4 minus small d raised to 4. Substitute the values, you get 14.672 into 10 raised to 6 mm 4. Okay. Here now actually this is hollow circular section, so Ixx is equal to Iyy, so no need to calculate again. So whatever you get, that is equal to Iyy also. Okay, now you know A and I. In the Rankine's formula, you have to calculate K, radius of gyration. That is nothing but square root of I divided by A. Substitute the value of I is equal to 14.672 into 10 raised to 6 divided by A. What is A? A is equal to 6361.725. Take the square root of this, you get 48.024 mm. Okay, this is radius of gyration. Next, what you have to do here, effective length you should know. What is the effective length here? Here one end is fixed and the other end is hinged. Here it is given one end is fixed and other end is hinged. So what is LE? L effective is equal to L divided by root 2. So I have given 4 end conditions. In that the L effective for one end fixed and other end hinged is L divided by root 2. What is L? L is equal to 2800 mm divided by root 2. So you get effective length is equal to 1979.9 mm. This is effective length. Now you know what is E, you have what is the value of I, and you have LE also. So you can find Euler's crippling load. What is Euler's crippling load? That is PE is equal to pi square EI divided by LE square. Okay, that is effective length LE square. So that is pi square into 80 into 10 raised to 3, that is E, 80 into 10 raised to 3, and I is equal to what is I? 14.672 into 10 raised to 6 divided by L effective, that is this is L effective. Okay, LE. You can write LE is equal to 1979.9 whole square. Simplify this, you get 2955.24 kilonewton or 2955.24 into 10 raised to 3 Newton. So this way you can calculate Euler's crippling load. So next step what you have to do, you have to find the Rankine's crippling load. What is Rankine's crippling load? The formula is P Rankines is equal to sigma C into A divided by this is R. Okay, Rankine's formula is equal to sigma C into A divided by 1 plus alpha into L divided by K whole square. This is always L is L effective. Okay, here. So substitute sigma is equal to 550 into area is calculated 6361.725 divided by 1 plus alpha is given, that is constant, Rankine's constant, 1 divided by 1600 into LE, that is effective length 1979.9 divided by this is K is equal to 48.024. This value you got here from this. Okay, substitute, you get 1696.62. This is Rankine's crippling load. Now it is asked to compare the buckling loads obtained by Euler's formula and Rankine's formula. So just compare first Euler's crippling load divided by Rankine's crippling load, PE divided by PR, that is equal to Euler's crippling load is 2955.24 and Rankine's crippling load is 1696.62, so 1.742. So how you can compare? Euler's crippling load is equal to 1.74 times of Rankine's crippling load. So like this you can compare. Okay, so Euler's crippling load is equal to 1.74 times of Rankine's crippling load. Okay, now next question, what it is, you have to calculate the length of column for which both formulae gives the same load. Means now you have the load, okay, that should be same, and you have to calculate the length of the column. Okay, already you know what is the length, but in this case you cannot consider that, you have to calculate the length. So for the given condition, length of the column for which both the formula gives the same load. Okay, so that means PE is equal to PR. Euler's crippling load is equal to Rankine's load. Okay, now Euler's formula, that is pi square EI divided by L square is equal to sigma C. This is Rankine's formula, sigma C into A divided by 1 plus alpha into L divided by K whole square. Okay, now what you have to calculate here means the length you have to calculate. So only one unknown is the length. Okay, so that is L. So substitute all the other values. Pi square, E is 80 into 10 raised to 3 into I is 14.672 into 10 raised to 6. L we don't know, we have to calculate. So let it be like that only, L square. Okay, this is L square means it is L effective. Okay, this is L effective. So whatever you get, that answer is equal to L effective. Okay, all the formula, it is L effective. So this is L effective only. Okay, so here in this sigma c is 550 into A is 6361.725 divided by 1 plus alpha is equal to 1 divided by 1600 into LE divided by K. LE we don't know, so let it be like that only. K is 48.024 whole square. Okay, LE square, I have considered this separately, although it is LE divided by whole square, we will consider that LE square divided by K square. K is equal to 48.024 whole square. So simplify this, just multiply this and write here, and this also simplify and write. Okay, so yeah, I think all of you know the mathematics very well, so you can simplify. This is you should know how to simplify this. Okay, this is here, this step is just multiply this divided by LE square, and here also multiply, and this here you have to multiply 1 LE square divided by 1600 into 48.024 whole square. So you get like this. So then you can take the LCM of this. So this becomes now 3690 plus L square. So this is like this. So if it goes up, so you will get, simplify this. So you get, you can do this in the calculator. I think quickly you can do this. So you get L square is equal to, in terms of L square you get the answer. So take the square root of that. So that is equal to 5680 mm you get. That is nothing but 5.68 meter, but we want the actual length. So actual length is what, that is capital, I mean L it is. This what you got, this is effective length. Okay, this is effective. So what is actual length here? Both the one end is fixed and other end is hinged. So LE is equal to L divided by root 2. So we have L effective, so L actual length is equal to LE into root 2. So this is whatever the answer you got, that is 5.68 LE into root 2. That gives the value of actual length, that is equal to 8.033 meter. Okay, so like this you can calculate what is the effective length of the column, and then you can find the actual length of the column. So here three calculations are there. First you have to find Euler's crippling load, then Rankine's crippling load, then you have to compare. That is first step. After that you have to find the length by equating the loads. Okay, both the, it is given the condition both the loads are same, so equate that, only one unknown L. So calculate this, you need to practice, otherwise you went wrong, you may get went wrong, or you may do the mistakes while calculating. So do practice on this. Okay, I hope all of you understood. If you have any difficulties, we can discuss in the class. Thank you.